Okay, here I'm going to do you a graphic organizer for exponential versus logarithmic functions. Now I'm going to go ahead and graph each of these for you, and then we'll talk about the different characteristics. 3 to the x minus 2 plus 1. Again, what you could probably do here is just graph y equals 3 to the x and use those transformations, move everything right 2 and up 1, and here's what your graph's going to look like. Now the different characteristics, the domain of an exponential function is negative to positive infinity. You can plug anything. Your range, notice your asymptote line is moved up 1 because of this transformation. It is now at y equals 1. So your range would be from 1 to infinity. Your y-intercept, now to find the y-intercept, we're going to have to plug in 0 for x here. So you're going to have f of 0, which would be 3 to the negative 2 plus 1. 3 to the negative 2, that's 1/9 plus 1, so that'd be 1 1/9. Your increasing interval, this is constantly increasing, never decreasing. And your end behavior, as you travel to the right, your graph goes up. As you travel to the left, your graph approaches that y-intercept, which is actually in this case, or excuse me, approaches the asymptote line, which is y equals 1. Your second graph, now it's identical to the first one, except for you can check this. You could actually flip-flop your x and y's, and what they've done is they found the inverse of the first graph. So I'm going to go ahead and graph this for you. And again, what I'd probably do is graph log base 3 of x, and then move all your points right 1 and up 2, and this is what it's going to look like. And another trick here that you can use for graphing this, log base 3 means 3 to some power gives you this. So you could plug in an x value that made this something easier that you know, like maybe plug in a 10 and you get 10 minus 1 is 9. And I know log base 3 of 9 is 2, so that made it a little bit easier. Now your domain here, again, notice what happens. Your domain, your graph starts at 1 and goes to infinity. The reason for that is because you now have a vertical asymptote at 1. Your range goes down and up forever, negative to positive infinity. Your X-intercept they're asking for now is 1 1/9, comma 0. Your increasing interval, this graph is constantly increasing for the entire life of it from 1 to infinity. It's never decreasing. And notice all those values that we wrote there. The domain and range here versus here, they're just flip-flop because these two functions are actually inverses. The x-intercept and y-intercept, those 2 points are flip-flopped of each other. The asymptote lines, x equals 1 versus y equals 1, are flipped because they are inverses. So finally, our end behavior. As we approach infinity, to the right, my y value goes uphill. As we approach 1, my y value is going to go down to negative infinity, which again, you see the x's and y's are just flipped from over here. Another one. Again, I'm going to go ahead and graph that. 1/2. Now, one thing I would definitely do here, you have a negative exponent. So 1/2 to the negative x, why not go ahead and flip that 1/2 and turn it into a 2 and make it a positive x? So we're simply doing y equals 2 to the x minus 5. Let's plot those points and graph it. And there is your graph. Notice it is just 2 to the x power, and then it's been shifted down 5 units. Your domain here is all real numbers for exponentials. Your range, your asymptote line, since it's got shifted down to -5, that means your range would be from -5 to infinity. Your y-intercept is located right here, and that's at 0, -4. You're increasing for the life of the graph from negative to positive infinity, and you are never decreasing. And your end behavior, as you travel to the right on your graph goes up. As you travel to the left on your graph approaches that asymptote line of -5. Next up, let's go ahead and graph. Let's see if these are inverses of each other, and they should be. If you were to turn this into a y and change it into x equals, let's change this, 2 to the y power minus 5, rewrite that as a logarithm, you should get this same logarithm over here. So let's go ahead and graph it and see what it's going to look like. And there you see a picture of your graph. Now notice again, these two functions are simply mirror images across that line y equals x because they are inverses of each other. Your domain value, let's start out with our asymptote line because since we have a vertical asymptote at -5. Again, it got shifted left 5. Since you have that vertical asymptote at -5, that tells me my domain is from -5 to infinity. Your range goes down and up forever. Your x-intercept is going to be the same as your y-intercept before, just flip-flop, -4 is 0, and it is located right there. Your increasing interval, this function is constantly increasing from that -5 forever, so therefore it is never decreasing. And your end behavior. So as you go to the right on your graph is going uphill, so your y value is approaching positive infinity. Then as you get closer and closer into that asymptote line of -5 to the left, your graph approaches negative infinity. Let's graph y equals 2 raised to the 3 to the 3 times x plus 1 power minus 4. You can use transformations if you would like here. And you could actually do this. 2 to the third power, you could change that to 8 to the x plus 1 power minus 4. That might be a little bit easier. And then simply graph 8 to the x power and then shift all the points left 1 and down 4. Here's what it's going to look like. So there is your graph. Domain for an exponential function is all real numbers. The range, let's find your y-intercept, or excuse me, your asymptote line first. Your asymptote line is y equals -4. Again, it got shifted down 4. It's normally y equals 0. So therefore, your range is going to be from -4 and up. Your y-intercept is right here at 0, 4. And again, the way that you could find that is you could plug in 0 for your x and do 8 to the first minus 4. You're constantly increasing the entire domain, and you are never decreasing. Your end behavior, as you travel to the right on your graph, as you travel to the right on your graph increases without bound uphill. As you travel to the left, your graph levels out to your asymptote line, which was at -4. Now let's graph the inverse of that function, and again, we can simply take those same points and just flip-flop our x and y's, and here's what it's going to look like. Now let's go through all the parts. Our domain here starts at our asymptote line. So we have an asymptote line here of x equals -4. Again, it's normally x is 0, but it got shifted left 4. So therefore, my domain would be from -4 to infinity. My range, my graph goes down and up forever. My x-intercept is at 4, 0, which is located right here. You can find that by plugging in 0 for y if you would like to and solving it. Next up, my increasing interval. My graph increases for the life of the graph. That would be from -4 to infinity. So therefore, it never decreases. And finally, my end behavior. As x approaches infinity, or as we travel to the right on my graph increases without bound. As we get closer to -4, which is my asymptote line on my graph, my y decreases. So it approaches negative infinity. Okay, the next one. Doing a base E here. So let's take a look at the graph of this function. And you can actually notice I use Desmos here. You can use Desmos with if you need a little help graphing these. The domain, again, you can plug in anything from negative to positive infinity into these exponentials. You do have an asymptote line here of y equals 0, so therefore your range will be from negative infinity up to that 0. Notice your graph did get flipped, and that's the reason it's down at the bottom. Your y-intercept, again, to find your y-intercept, you can plug in 0 for this x, and you're going to get 0, comma, that'd be e to the -3, and then multiply that answer by -1/4. Again, you could go back to your Desmos if you would like to, and notice right here is where we plugged in 0 for x, and I got -0.012. -0.012. You're increasing nowhere because your graph is constantly decreasing from negative infinity all the way to positive infinity. Your end behavior, as you travel to the right on your graph decreases forever. As you travel to the left, that's where your graph starts leveling off to your asymptote line. Next up, the inverse of that, it would be the natural log of -4x plus 3. Let's take a look at its graph. And there you see a picture of the graph. Now I did again use Desmos to help me a little bit so I wouldn't have to type all these values in. And notice I left the previous graph on there as well. These are perfect mirror images. They are definitely inverses of each other across that line y equals x. Your domain here, you can only plug in values. Notice there's no graph over here, so your domain is from negative infinity up to 0. Notice the flip-flop of the range from before. Your range is going to be all real numbers. Your X-Intercept, again, is going to be a flip-flop of the Y-Intercept from before. That's going to be negative 0.0120. The asymptote line, again, occurs at the Y-intercept. It's going to be x equals, or excuse me, the Y-axis. It's going to be at x equals 0. Your function does not increase. However, it is constantly decreasing from negative infinity all the way to your asymptote line. And then finally, your end behavior. As you travel, and that's not going to be as x approaches infinity, that's going to be as x approaches your asymptote line. So as you travel to the right towards that asymptote line, your graph goes downhill. As you travel to negative infinity, your graph approaches positive infinity. So that should be y approaches negative infinity, and then positive infinity to the as you go to the left.